Hello everyone, welcome to another time with the enthusiastic tutor. In today's tutorial, we'll be taking the course Industrial Organization Psychology, and this is going to be the fourth class. It's a series, and in today's tutorial, we'll be treating the topic under Industrial Organization Psychology, Ergonomics. So we're taking the topic Ergonomics. So sit back, relax, get your writing materials, and let's hop right into it. So we have, what is ergonomics? Ergonomics is efficient, effective, man-to-machine system. This is a system which is efficient and effective, categorized by the interaction between man and machine. Now, this system is based on understanding of human factors as important inputs in machine and equipment design. Understanding the human factors in making this machine and equipment designs working effectively. Engineering psychology or human factor engineering is another name for the subfield of psychology. As we have said, engineering psychology or human factor engineering is another name for the subfield of psychology called ergonomics. As you just read from the explanation just given, economics, ergonomics is an subfield in psychology, and it could also be referred to as engineering psychology or human factor engineering. So we have that as that. Now it is concerned with man to machine fits at work with the consideration of core human factors in the design and the use of equipment and machine at work. Now, the main research focus are achieving man-to-machine fit. Man-to-machine fit in the sense that man and machine can communicate effectively. Man and machine can put the combination of both efforts to achieving a greater result. We have reduction of industrial accidents. We have guaranteeing industrial safety and security, and we have optimizing performance. Just as the 4 bullets as listed, achieving man-to-machine fit, or just as I've explained earlier, man-to-machine fit in the sense that man and machine can both be combined and used at work to achieve greater results. Industrial accidents should be reduced. The effectiveness of man and machine fit should reduce industrial accidents in the sense that availability of machine at work will increase work productivity and reduce more of accident, as machine will be the major frontier of work and doing things. Man will be in charge of controlling the machine. We have guaranteeing industrial safety and security. The effective use of machine can definitely guarantee industrial safety, as a lot of measures will be put in place, and the work of man in fronting of the activities will definitely be in a safer mode. So we have optimizing performance. The combination of both man and machine definitely will optimize performance. So we have that as that. Let's go to the next slide. So we have designing work for people. Now, until the 1940s, designing of industrial plants and machines were the sole responsibilities of engineers who usually make design decisions without due consideration for the workers who operate them. Now, this is our illustration of what it was like in 1940s when work is being designed. Industrial plants and machines were the sole responsibilities of engineers, and unfortunately, human part of work design is not being actually considered well by the engineers then. Now, thus, human beings have to adjust to the features represented in those machines with considerable strain and higher degree of error and accident and other machine-induced stress such as fatigue, cramps, eye and headache, etc. Yeah, so human beings have, with the kind of settings, with the kind of design done by these engineers, with how factoring, how safe, how conducive it could be for humans to fit in a work with machine. So human beings had to adjust to some unfavorable circumstance, and cramps and eye headache and so lots more and stress. So a lot more. So we have more so machines and equipment, especially military hardware, as used in the World War II, became increasingly complex and requiring increasing level of speed and precision for their operation. Now, it's just an analogy that then man can't really fit into the work conditions of machine because of how terrible things were designed using the machines. So let's just go to the next slide, and we have this place great demands on capabilities not only upon muscular strength but also higher level abilities of sensing, perception, judgment, and decision making. Now, very true. As this work environment is not conducive, definitely it's become a great demand of capability. Now, you require a greater demand of capability and a muscular strength and higher level of sensing, perception, judgment, and taking of decisions. No, now, but another possibility was in the off brain. Now, the time motion study of Frederick Taylor and the Gilberts were precursors for the understanding of the number, just understanding of the need to adapt machine to human attribute as opposed to other way around. Now, this is what ergonomics is all about. Now, ergonomics is coming into the picture now as the study of time motion by Frederick Taylor and the Gilbert, were coming into the picture, and the introduction of ergonomics was discovered. Now, ergonomics was discovered, it came into the picture as all this, as how terrible humans have not been able to fit into machine based on the design done by some certain engineers. But all credits to Frederick Taylor and Gilbert with the study of time motion that brought into existence of ergonomics, I beg your pardon, designing machines and equipment that fit into human psychological and cognitive ability as well as other attributes, sociability, emotionality, and so forth. Now, bearing in mind all these environments of usage. Now, it's just all about putting into consideration when the use of machine is being presented at organization, is just about bearing in mind the operators of this machine, how conducive can they be, and how well can they fit into using the machine. Now, today, the 21st century, workplace is becoming increasingly automated by technology, increasingly competing for space, time, opportunities with man. That's it. So now that it's more conducive to use, as you can see, in 21st century, now the use of automation and technology is on the high side. It keeps increasing daily. So we have that as that. So we have types and characteristics of technology. We have the types and the characteristics of technology. Now, technology in today's context can be interpreted broadly according to Mullins 2007. Mullins 2007. So we have the physical aspect of machine, we have the equipment, we have the processes and work layout, machine technology involved in the transformation or conversion processes. This is interpretation of what technology is now broadly, and we have number one as the physical aspect of machine, meaning the equipment, the processes, and the work layout. So we have the actual method, systems, and procedures involve knowledge technology in carrying out the work of the organization and in transformation and conversion of inputs. Now we have the technical know-how, the actual method and the approaches, the actual method, the system and the procedures involved in the use of this machine in carrying out certain tasks. We have the technical know-how, which is that we have the physical side of technology refers mainly to microelectronics and microprocessors. Now, the physical side of technology is basically referred to as microelectronics and microprocessors. Now, the information and communication technology, ICT in bracket, applicable in manufacturing, information sharing and processing, service provision as product themselves. Now, that's the ICT. We have the physical side of technology refers mainly to as microelectronics, and we have microprocessors. Those are the physical side of technology. So we have types and characteristics of technology. So we have under the ICT, we have the manufacturing, engineering, design equipment, often referred to as advanced manufacturing technology, which are ATM or computer aided engineering. So we have advanced technology manufacturing. So we have advanced manufacturing technology, and we have computer aid engineering, which is ACE, and we have the advanced technology manufacturing, which is ATM. So we have technology for information capturing, storage, transmission, analysis, and retrieval, like computer that may be linked with the advanced manufacturing technology. We have technology employed in the provision of service to customers, patients, clients by the use of service sector applications. We have technology is a product. All these are under the physical side of technology, which is referred to as microelectronics and microprocessors. The information communication technology application is manufacturing, information sharing and processing, service provision and as a product themselves. Now, the main forms of applications are, which we have the ATM, we have the CAE, and under those we have technology for information capturing, storage, technology basically for information, and technology employed in provision of service to customers, and we have technology as a product. So we have factors to consider according to AZA 2004. Information flowing from the machine to the operator is a form of interaction involving the use of human capacities to sense, to perceive, to process, to retrieve, to control, levers, or manipulate one aspect of a system or the other. And these are the factors to consider. And according to AZA 004, information flowing from the machine, which is the output, to the operator on the interface or displaying machine in form of an interaction. Definitely there's an interaction between the user and the computer involving the use of human. Now definitely this has a large share on the involvement of human capacities to sense, to perceive, to process, to retrieve, control levers, or manipulate one aspect of a system or the other. So that can't be overrated. So we have factors for considering in control design. We have the type of control, talking about considering the control design. We have the type of control which is in question. Now the control should be of factors for consideration in control design. Now the first thing we have is a type of control. Now the control should be operable and follow as much as possible the natural motion of the operator, especially in terms of relative applicable force and limb positioning, as so as not to cause muscular ache and fatigue. Now, talking about the type of control, now the control should be actually operable and follow as much as possible the natural motion of the operator, meaning that the operator should be able to operate the machine efficiently. The machine should not be faster or should not be stressful to operate. Now, especially in terms of relative applicable force, the limb positioning as of do not cause muscular ache. Now, applying force, as I said earlier on, the machine should not be faster or too slow in order for the user to be able to use the machine effectively. We have the presence of resistance. Sufficient but reasonable resistance is necessary to avoid superior input from the operator. Now, speaking about resistance, it should be reasonable in amount. So we have the interface. Now the surface of a control system, depending on the type of operation, should either be smooth or straightened. Now hand operated system could be smooth, while leg operated lever should be straightened for the necessary grip. Very well, as well, self-explanatory. So we move to the next thing. We have factors for considering in control design. We have 6 now. We're on the number 6th factor. We have the control shape. Designing the control interface shape is important for firm grip and elbow room for movement. So we have control shape. Now the shape of the control should be well-designed. Interface should have a well-designed interface for perfect grip and the elbow room movement. So we have that as that. So we have number 7. We have one hand and two hand operation. Now the society is populated by a mix of right-handed southpaw individuals that are ambidextrous. Now this unique need of these individuals have to be borne in mind, while at the same time one hand versus two hand control are all requirements for coordinating eye and leg should be received attention in equipment design. Now there are some persons we have them as one hand, they use just one you have one hand effectively, that the active hand is their right hand. So all this thing has to be put into consideration. And we have some, the active hand is just their left hand, and so we have all those things should be put into consideration. So we have the feedback. The control system feedback should be so positioned as to process input and relay action and output in indecipherable code and or language. Now indecipherable, now output indecipherable. Now the code and language should be comprehensible by the user. So we have that as that. So we have factors for considering in display design. We have, it is important that display design are embedded in both the system and the environment. Very well. Now the system and the environment should be embedded with important factors. For instance, failure due to electricity are first discovered by either by the ear when the humming sound stops, or eye if the lightning diminish or goes out. For instance, the dashboard is programmed to relay multiples of information ranging from fuel level, functioning of hydraulic brake system, acceleration, speed, mileage, we have temperature, geographical information, and so forth. Now this is the dashboard of the machine, and those are the things it should display. We have this put the sensory center and peripheral nervous system. It is on alert. Now designers should therefore bear all this in mind. In cases where things goes wrong, the dashboard should display all the aforementioned, and the designer therefore should bear all that in mind. So we have that as that. Excuse me. Factors for concentration in display design. We have the natural format. Now we have formats that are unfamiliar to natural human attributes, require time to become accustomed to. Reading and interpreting signals that are not familiar to normal habit patterns are likely to increase error rate. So make it a natural format, make it a format that could be comprehensible by the operators. Now precisions of response. Now we have requiring operators to become more precise than necessary, that is normal response threshold. Now we have may have to fatigue and cause them to make judgmental errors. For instance, the difference between without and pre-spotting accuracy and true accuracy has to be factored in. Definitely precision of response, you have to give direct and clear information on the system or the machines. Now we have operator view technique. Now the display technique has to be matched to the operators boldly constrained viewing environments, conditions like lightning, acceleration, vibration, mobility, restriction, and the position. Operation view technique, it has to be the lightning, the vibration, acceleration, mobility, all has to be properly viewed without constraint. So we have that as that. So we have the factors for considering in display design. The fourth one, we have use of simple concept. Display that they use complex. Display that use complex signs and symbols are difficult to interpret and understand, and without extensive training may lead to increased error rate. Now, to cut down error rate, use simple concept. It's very important for the session now. On the whole, display system must be conspicuous, legible, visible, and readily interpretable. So we have that for the display system. So we have technology and the new phase of work. Now the truth is the phase, form, structure, and pace of work have changed in such a dramatic fashion over the last 2 decades. You can agree with that. Not only as technology, equipment, machine, ICTs, and robotic engineering have influenced work and job designs, it has influenced human behavior at work, its job roles, areas of latitude, and tenure. Now, organizational research shows that technology influences behavior of people in work setting. Absolutely. Technology influence behavior of people in work. Absolutely. Now, we take these, the specific design of work and the knowledge, skill, and aptitude needed to do them. We have the specific design of work and the knowledge, skill, and aptitude needed to run the technology. We have influencing how work is organized and controlled, affecting the pace and intensity of work, reducing the number of people that has to participate in getting a product off the assembly line, and adjusting overhead and other disciplinary issues related to individual and organized body of workers. These are all positive effects technology has upon influence on work at organizations. So we have technology and the new phase of work. So whereas technology has fundamentally affected how work is designed in terms of structure, processes, and expected behavior, thereby reducing marginal control and freeing management from burdensome bureaucracy to focus on germane important issues of quality, improved work conditions, and motivation of employees for cutting edge performance. Technology has equally created certain problems. Now, all those things are the positive things technology has done, as you can see here, to help the management focus more on how to improve the work quality and how to improve individuals and discover some abnormalities, and that even as much as technology has brought all disadvantage, it sure does has disadvantages as well. So we have technology and the new phase of work. We still continue on that. So we have free flow of information which erodes into managerial prerogative of information management and official secrecy. So this is actually one of the advantage. It's a free flow of information which erodes into managerial prerogatives of information management and official secrecy. We have over dependence on automated solutions that have reduced human initiative, creativity, and removing intrinsic motivation component of work. So we have devotion of official hours to personal use of social media. Okay, this seems more of the disadvantage. I'm just going to take that to the previous slide. Okay, we have challenges right away. Yeah, those are the challenges. Now the problems. We're talking about the problems and the challenges. So these are the challenges and the setback of technology in work. So we said something about the free flow of information, uncurbed information flowing. So we have which have led to managerial prerogatives of information management and official secrecy. There are no secrecy. Sometimes, it's erode into their managerial prerogatives. So you have the over dependence on automated solutions. So human beings, the using of initiative by human beings are reduced because of technology. We have the devotion of official hours used to in the use of personal use of social media. So we have that as that, which can limit productivity. So we have the informality and speed of electronic communication are of great attraction as well. Now informalities, okay, We have that as that. We have the use of ICT as a means of mounting surveillance on employee, which may compromise their privacy and certain fundamental right. So those are the disadvantages. So we have the workplace therefore has to find a balance for the advantage and the disadvantages of ICT and the new mode of work, such that jobs are protected along with human dignity. So we have social ethics and within reasonable legal regimes of operation. Very well, there has to be a strike, a balance. Balance has to be strike. So we have conclusion. The overall goal of equipment and machine design is to facilitate as well as complement human effort at work. Absolutely. There are several types of useful technology in today's workplace, ranging from simple to sophisticated, like industrial robots. So there are factors to consider in building and installing industrial machines. Affirmative. Now, though new age technology and the world of work is changing dramatically, now the basic features of machine remains input, processing, and output, and we have feedback system. And that is conclusively, holistically, and that is it. So thank you very much. We have the overall goal of equipment and machine design is to facilitate as well as complement human effort at work. It is not substitute human effort, but rather it's to complement human effort at work. So there are several types of useful technology in today's workplace, ranging from the simple to the sophisticated, like industrial robots. So there are factors to consider building and installing here. So we have, I think these are like more of a repetition. That's more of a repetition. I think we have that good, and this brings us to the end of today's class. Thank you very much, and I look forward to seeing you in the next one. Bye bye.